Okay, so we're continuing on with the same scenario, but we're going to go to create a 90% confidence interval for the amount of time spent texting and interpret the meaning of the confidence level. Does the confidence interval supports Jenna's claim? Justify your response. Well, to speed things along, I'm going to say, see previous video for the condition, see previous video for the definition. So at that point, I can go ahead and skip on to the formula. The formula for one sample confidence interval is T equals X bar, excuse me, wrong, X bar plus or minus T star S divided by the square root of N. All right, so once again, please always identify your X bar, and our X bar is the sample mean, which is 96.3. This is the supposed population mean, that's the claim mean, but the confidence intervals are based on the sample mean. So I'm going to start plugging in what I know, and I know it's 96.3 plus or minus. I'm going to leave a space for T star because I don't know that off the top of my head, and I'll come back to that in just a moment. I know the standard deviation was 8.3, and I know my sample size was 39, so we're taking the square root of 39. Well, that means my degrees of freedom is going to be 39 minus 1, which equals 38. Well, so now I need to go back and calculate T star. So going back and calculating T star, I'm going to go to second, followed by vars, select inverse T, and parenthesis 1 minus 0.90%, so 0.90, divide by 2, and degrees of freedom, we said were 38, and you can put in 39 minus 1, or you can put in 38. And this is going to give me a T star value, and we're going to just make it positive of 1.6859. You must show this statement. You must be able to calculate T star. I know you can jump. I know the calculator will jump directly to the interval, but if you can't get that value, you're going to have a problem. You're going to lose a lot of points. So here we go. Stats, test. And we're doing a T interval. So I'm going to scroll all the way down to number 8, which is T interval. And I have 96.3 is my sample mean. Make sure you're using the sample mean because it's X bar, my sample standard deviation, and my N of 39. I'm going to make one little comment real quickly. The reason we're using T as opposed to a Z is because we're working with the sample standard deviation. All right, I should have said that on the other video, but sample standard deviation is what makes us work with the T. Oops. And my confidence level needs to be 0.90. And so now I have my interval. And my interval ends up being 94.059 and 98.541. So this is my lower, this is my upper. And real quickly, this means my lowest plausible value is 94.059. My highest plausible value based on our interval is 98.541. Any value in between is plausible. Any value outside is not plausible. Also, because this is a 90% confidence interval, we're 90% confident that it lies within this interval. Conversely, we're also at the exact same time, we're 10% confident that we're wrong and it lies somewhere outside of it. Where outside, we don't know. It could be above, it could be below, but we are 90% confident that it lies within this interval, which means we're 10% confident that it lies somewhere here, above or below. And please note, every value within the interval is considered plausible. So we need to write our conclusion. We are 90% confident that the true population mean texting time, or amount of texting, but texting time lies within the interval 94.059 to 98.541. All right, the next thing is we need to interpret the meaning of the confidence level. All right, and that's where we're going to make our in repeated sampling. And I'm going to pause for just a moment and talk about in repeated sampling. This means if I did it over and over and over again, specifically if I did it an infinite number of times, or if I did all possible combinations, 90% of them would contain the interval. Contain the population mean. Conversely, that also means if I did it for every single possible sample, 10% of the intervals would not be successful in capturing the true population mean. So we're saying, hey, 90% of the time we're right, 10% of the time we're wrong, and it won't lie within the sample. So in repeated sampling, we expect that our super awesome method, our method, or this method, will capture the true population mean texting time 90% of the time. All right, so the next thing, does this interval support Jenna's claim? Well, what was Jenna's claim? Jenna's claim was that the HA, the mu, was actually greater than 94 minutes. That was her claim. Well, when I look at this interval, does it include 94? And the answer is no. It's above 94. So, yes, this interval supports Jenna's claim. I get no points for that answer, even though it's correct, because you had a 50% chance of guessing that. I have to justify it. Why? Because the interval does not contain 94 minutes and lies which way? Above it. And lies above 94 minutes. If it had been below 94 minutes, it also wouldn't have supported the claim, because then it would have been saying that they do it for less than 94 minutes. So you have to tell me whether it's lying above or below, since you made the claim of greater than, right? Because she made the claim of greater than, we needed it to lie above. If she made the claim of less than, we needed to lie below. If she said it was different than, then we wouldn't care which way it was, as long as it didn't contain it. Okay? All right, I'm going to pause this and try to answer questions if there are any. So one of the questions that was asked is if we said that the interval contains 96.3 and did not mention that it was greater than 94, would that be okay? And the answer is no, that's not okay, because we have to, all we're worried about is where the mean lies, and whether the mean lies within the interval. It's plausible that I could have had an interval that was as low as 93 and as high as 95, in which case 96.3 lies within the interval, obviously, but so does 94. And it's because 94 either lies within the interval. If it lies within the interval, we cannot support Jenna's claim. But if it doesn't lie within interval, then we can support it. It has to be the population mean that drives our decision making, not where the population mean lies that drives the decision making.